Hello everyone, welcome to the action log. This is my first video. It was supposed to be uploaded yesterday, but the editing took more time than I thought. Yesterday I was a bit busy, so I was only able to solve the lead code daily. So, without further ado, let's get started. The question is, you are given a 2D matrix and a variable k as input. K represents the number of times the grid needs to be shifted. There are three cases of shifting. First, grid I, j moves to grid I, j plus 1, which means every element moves one position ahead. Second, grid I, m minus 1 moves to grid I plus 1, 0, meaning the last element of a row becomes the first element of the next row. And third, grid n minus 1, m minus 1 moves to grid 0, 0, which means the last element of the entire matrix moves to the very first position. Let's start with the brute force approach. As you can see in the code, we first initialize two variables, n for the number of rows and m for the number of columns. Then we take k modulo open parenthesis n times m close parenthesis, because the matrix starts repeating after n times m shifts. Now, look at the loop. We iterate over the grid from the last position. We store the last element in a variable and start shifting the values based on the three conditions we just discussed. It's a very straightforward approach. We're basically simulating exactly what the question asks us to do. The time complexity of this approach is O of k times n times m, and the space complexity is O of 1 since no extra space is used. Now, let's move on to the optimal approach. Here, we first need to recognize a pattern. If you observe the example shown on the screen, you'll notice that the kth element from the end becomes the first element after shifting, and the remaining elements continue in the same order. For example, if k equals 4, then the fourth element from the end is 12. So 12 becomes the first element, followed by 0, 21, 13, and so on. Once you reach 13, which is the last element, you continue from the first element of the original grid, which is 3 in this example, and keep traversing until the element just before 12, which is 10. This observation gives us an idea of how to solve the problem more efficiently. For the optimal solution, we can use the concept of converting a 2D array into a 1D array. By converting the grid into a 1D array, the required traversal becomes much easier. If you look at the first loop, you'll see that we're storing all the elements in an array. Then, in the second loop, we initialize an index that points to n times m minus k in the 1D array. After that, we iterate over the grid normally, assign values from the 1D array back into the grid, and increment the index. Whenever the index goes out of bounds, meaning it becomes equal to n times m, we simply reset it back to 0. The loop then continues as before. Since the grid and the 1D array have the same number of elements, we don't have to worry about index misalignment after resetting it. The time complexity of this approach is reduced to O of n times m. However, we do need extra space to store the grid as a 1D array. So the space complexity becomes O of n times m. Our development part was also supposed to be included in this video, but I didn't get enough time to work on it. Maybe I'll cover it in the next one. Till then, have a great day. Keep learning, keep building, and keep improving. Thank you.